Hello friends, here in this video we are going to start a new chapter in thermodynamics, and the name of the chapter is gas power cycles. Now, in gas power cycles, here we are having the term gas. This gas is nothing but it is called as a perfect gas, and even air can sometimes be treated as a perfect gas. And what is perfect gas? First I'll write it down, that perfect gas is a gas which follows all the gas laws, that is Charles law, Boyle's law, Gay-Lussac's law, and Avogadro's law is called as a perfect gas. So, here I have written the definition of a perfect gas, that it is a gas which follows all the gas laws, that is Charles law, Boyle's law, Gay-Lussac's law, and Avogadro's law is called as a perfect gas. Next, I can say that if, for example, if simple air which is there around us, if that air follows all the above gas laws, then it can be treated as a perfect gas. So here I have written that when we are talking about air which is there surrounding us, that air, if it follows all the gas laws, then we can treat even air as a perfect gas. Next, I can write down one more point here, that a perfect gas will have two specific heats, and they are: first, specific heat at constant pressure; second, specific heat at constant volume. So here I have written that a perfect gas, even air can be called as a perfect gas if it follows all the gas laws. Then a perfect gas will have two specific heats, that is specific heat at constant pressure and specific heat at constant volume. The specific heat at constant pressure, it is denoted as C suffix P, and specific heat as at constant volume is C suffix V. And as we can see, there are two specific heats for a perfect gas. Now, when we are talking about gas power cycles, here we have understood what is the meaning of a perfect gas. So in gas power cycle, we have a perfect gas as the working fluid. I'll write down that in case of gas power cycles, here we are using gas, or sometimes we can also call it as air, as a working fluid, or we can say working medium. So your gas, as we have understood, it is a perfect gas, and gas can even be said as gas can be taken as a mixture of air and fuel. Like for example, if we are mixing diesel with air, that will be called as a gas, or if we are mixing petrol with air, then it would also be called as a gas. That is, gas is a mixture of air and fuel. And if we can see that in case of internal combustion engines, the quantity of air is more than that of fuel. So here the point is, when we have internal combustion engines, that is inside the engine, the quantity of air is more than that of fuel. So now here I have written that in case of internal combustion engines, the quantity of air is more than that of fuel. So sometimes what happens is that the gas power cycles are also called as air standard cycles. So here gas power cycles can also be treated as air standard cycles, because in case of IC engine, the amount of air inside the engine is more compared with that of fuel. So we can treat a gas as an air, and this air, it should follow all the gas laws to be called as a perfect gas. After this, next I'll give a brief introduction that what happens inside an IC engine. I'll see that this heading, it is the processes that take place in an internal combustion, that is IC engine. So here I'll mention the processes that take place in an IC engine, and the processes are: first, it is called as suction; second is compression; third, it is expansion; fourth, it is exhaust. So these are the processes, these four processes which take place in an IC engine, and I can explain them in such a way that, first of all, during suction, we can say air or air fuel mixture. If it is diesel engine, then at that time only air comes inside the cylinder, and after that the fuel is injected. But in case of petrol engine, air and we can say the fuel, that is petrol, they mix out of the cylinder and then come inside the engine. So during suction, we can say that charge, which can be air or air plus fuel, is drawn into the engine due to downward movement of the piston. That is, when the piston moves down, at that time in the cylinder of an IC engine, suction is created, and when suction is created, pressure falls below atmospheric. And here I'll write down that the charge is taken inside the engine because pressure inside is less than atmospheric pressure. So the charge will be taken inside the cylinder as the pressure when the piston is moving down in the cylinder, at that time suction is created, and because of the created suction the atmospheric air, or we can say air fuel mixture, they would be coming inside the engine because atmospheric pressure is more than the pressure inside the cylinder of an engine. So in this way the charge comes inside the cylinder. Next, during compression, I'll say that after the charge has entered the engine, when the charge is entering the engine, at that time the valves are closed, because if it is 4-stroke engine there is valve inside the engine, or we can say cylinder, and if it is 2-stroke engine then there are ports. So we can say that once the charge has entered, if I am assuming that it is a 4-stroke engine, I can say that both suction and delivery valves are closed. Then after that piston moves up. Piston moves up, it means that is it will move from bottom dead center, that is BDC, to top dead center, TDC, thereby compressing the charge inside the engine. So here we can say that when the piston is moving from BDC to TDC, now this BDC and TDC term, it can be understood by drawing a diagram. Here I am drawing a diagram of a single cylinder internal combustion engine. Here I am just drawing the line diagram. Now this is the cylinder. Next, for this cylinder we have two extreme limits, that is, if I can say that it is a vertical cylinder, then the upper limit would be called as top dead center, and the bottom limit, it would be called as bottom dead center, BDC. Now inside this engine cylinder we have two valves. First, this would be the suction valve, also called as the inlet valve. Then there is delivery valve, or we can say exit valve. Now as I have explained that once there is suction, so for suction the piston would be there inside this cylinder and it would be reciprocating. So here I'll just draw the diagram of a piston, and this is a line diagram, and this piston is connected with the help of connecting rod to the crankshaft. So here I have a piston and this is the connecting rod. Now during suction stroke the piston would be moving from top dead center to bottom dead center, that is in the downward direction as I have explained, and during this downward direction movement of the piston, inlet valve will open and fresh charge will come through the inlet valve inside the engine cylinder, like this. The fresh charge would be admitted. Next, after this, after the charge has entered the engine, both suction and delivery valves are closed. Suction valve, that is the inlet valve, delivery valve, that is the exit valve, both are closed. So now here As we can see that once the inlet valve and exhaust valve both are closed, after that piston moves up, that is it will move from bottom dead center BDC to top dead center TDC, that is piston will start moving up. And when the piston starts moving up, both the valves are closed. At that time the charge which is there inside the engine cylinder, that will be compressed, compressing the charge inside the engine, and because of that there will be high pressure rise due to compression. So I'll write down that during compression pressure inside the engine cylinder rises, that is the pressure increases above atmospheric, that is I'll write down pressure goes above atmospheric pressure. So now once the temperature has reached above atmospheric pressure, at that time if I am assuming that this engine is a petrol engine, so here at the center we would be having a spark plug. I am just drawing a line diagram that this is the spark plug. So when the charge has been compressed, its pressure is high and even the temperature is high, then we would be giving sparking, and from this spark plug sparks would jump and they would ignite the fuel air mixture which is there inside the cylinder, and thereby an explosion is produced inside the cylinder. So I'll write down that after compression that is after the compression process, spark plug produces sparks which will ignite the air fuel mixture, and once the air fuel mixture has been ignited, then an explosion takes place inside the engine, because of which there is high pressure rise inside the cylinder. And once the pressure has reached a very high value, or we can say out of all the strokes or all the processes inside the engine, during the sparking of the fuel, at that time the pressure is very high, it is the maximum pressure inside the engine, and because of that there is an explosion which is taking place. And once the explosion has taken place, at that time the piston would be pushed down because of that explosion, that is piston starts moving from TDC to BDC in the downward direction. So we can say that hence piston starts moving from TDC to BDC at a very high speed, thereby converting the chemical energy of fuel into mechanical work. So once the piston has start moving from TDC to BDC, that is in the downward direction, piston is connected with the help of connecting rod to crankshaft. Here I am just drawing the line diagram of the crankshaft. This is just a line diagram of the crankshaft which is supported inside the bearings. So when piston starts moving down, connecting rod has connected piston and crankshaft. This is the crank shaft. So this crankshaft will start rotating, and once the crankshaft starts rotating, we can say that mechanical work has been produced, and that is possible because here the chemical energy of the fuel has been converted into the mechanical energy, that is the rotation of the crankshaft. And after we have completed up till here, that is after the expansion process is also called as power stroke. So when the expansion process or power stroke is completed, then the burnt gases as well as some amount of unburnt charge will be exhausted, that is will be removed from the engine cylinder. So after the expansion stroke, that is once we have completed the chemical energy into mechanical work, then the gases which are trapped inside the engine cylinder, both burnt gases as well as the unburnt charge, now they are sent out of the engine, and that process is called as exhaust. So piston will start moving from bottom dead center to top dead center, that is BDC to TDC. Again the piston is moving up, and while the piston is moving up, at that time this exit valve, or we can say the delivery valve, it gets open, inlet valve is closed, and whatever the gases are there, they are sent out of the engine through the exit valve. So piston will start moving from BDC to TDC. Inlet valve is closed and exit valve is opened. Therefore the gases inside the engine are exhausted or sent out from the engine to the atmosphere, and in this way all the processes inside an engine gets completed. So here in this video we have seen what is meant by a gas and how are the processes taking place inside an engine, so that we can understand gas power cycles in a better manner.